All right, this is the Garrett gas train. It is manufactured and sold by OFI Testing Equipment under our part number 151-00. The standard use for this apparatus, this gas train, which this is the gas train body here, is for testing for hydrogen sulfide. But you also can test for concentrations of soluble carbonates in solution. You have to use a filtrate. You cannot use a test sample that has any particles in it. But the concentration of soluble carbonates in a drilling fluid filtrate can be determined using this apparatus. Total soluble carbonates include carbon dioxide, as well as the carbonate ion and the bicarbonate ion. Typically, these bicarbonates are tested in a alkalinity test using methyl orange solution and phenolphthalein solution and sulfuric acid. That's a titration procedure which is somewhat ambiguous because people perceive endpoint colors differently. Everybody's eyesight is somewhat different. So the titration procedure has some potential problems. Not so when you test with the Garrett gas train. This, you get a good hard number as read by the carbon dioxide Draeger tube. This Draeger tube is sensitive to carbon dioxide and carbon dioxide only. The mud is acidified in chamber number 1. We add a 5 normal sulfuric acid solution to the test sample. That drives the carbonates out, the carbon dioxide out of solution and through the gas train, and basically we hook this up to a 1 liter gas bag. We fill the gas bag up with the tube going into the gas bag so we get a more uniform mix of the carbon dioxide. Then we attach a stopcock device to the gas bag, and this stopcock enables us to turn the airflow on and off with a with a stopcock valve. And from here we hook it up to a hose, and then we hook it up to our Draeger tube, sensitive to carbon dioxide, and then we basically pull all of the air out of the gas bag into the Draeger hand vacuum pump, which by depressing this will pull air into it. And so all of these are required for running the carbonate test using the OFI Garrett gas train. The stain length on these Draeger tubes is proportional to the amount, the total carbonate concentration in our test sample. Our test sample is just something that we made up here in the lab without any sophistication whatsoever. We used calcium carbonate powder, which is a reagent grade precipitated powder. And I just dumped an unspecified amount of it in water. All this does is this supplies us with carbonates to run the test. So I'm going to withdraw about, a small amount, about 1.5 milliliters, and I am going to dump that directly into chamber number 1. The next thing I'm going to do is I am going to attach the lid. Being very careful, I have a dispersion tube here, which is the same dispersion tube we use in the H2S analysis. I want to be very careful that it goes easily into chamber number 1. Also, my flow meter, I want to make sure that it matches up with the hole in the lid. Then once I get everything attached, I want to verify that my O-ring seals around the flow meter, around where the Draeger tube hole is, and also for chambers 1, 2, and 3, I want to make sure that my O-rings are in place and they're not pinched and in good order. And so everything appears to be in good shape. So I'm going to tighten down the lid. You want to rather uniformly tighten this without over-tightening, which it is possible to crack the lid, which is not something you want to do because they're expensive. So I have a good tight uniform mix. I attach my rubber hose to my pressure source here, and make sure that I get a good seal both here and both here. I want to ensure that my dispersion tube is about 1/4 of an inch off the bottom of the cell, which it appears to be, but maybe needs to go down just a little more. And then I'll tighten the nylon valve, making sure that everything is in good shape. I want to make sure my regulator T-screw is backed off. I have a nitrous oxide bulb in place. I'm going to release that one and puncture a new nitrous oxide bulb. These bulbs are pressurized to about approximately 900 psi, so they are high pressure vessels, so care should be taken with that. They are hazardous. We have to ship them as hazardous items when we ship them internationally or when we put them on an airplane. So we have our CO2 pressuring device ready to go. I want to attach my rubber hose from chamber number 3 to my stopcock assembly. And on the other end, I want to attach, and I want this to be, the valve to be open so I can get flow through it. On the other end, I want to attach it to my 1-liter gas bag, just by pushing it in the holder here and rather tightly, making sure that I have a good seal there. So the bag and the hose and everything are ready to go. So the next thing I want to do is I want to add 10 mils of sulfuric acid to my chamber number 1. I have a beaker of acid that I have already poured out, so I'm going to, using a 3 mil syringe, I will inject this through the rubber injection port. There is 3 mils. There is 6 mils. Nine mils. There's 10 mils. So we are ready to go. So what I'm going to do, I'm going to initiate flow carefully because I don't want to hit this with full nitrous oxide pressure. I'm going to watch my dispersion tube here for bubbles, and we're going to fill this gas bag. So I'm now getting a flow. Apparently I've not punctured the CO2 bulb or the nitrous oxide bulb. All right. Okay, you can see the bag is inflating. And once it gets inflated, then I want to stop it by sealing off the stopcock. So I can also back off on the regulator T-screw so that I'm no longer putting pressure into the Garrett gas train. So now what I'm going to do is I'm going to remove the rubber hose from the number 3 chamber. And once again, my bag is sealed off with the stopcock here. So I'm going to remove the hose from the number 3 chamber. I'm going to take my Traeger tube that's sensitive to CO2. I'm going to take my device that is used to break open both ends of. I insert it and just twist. It's that easy. So I want to make sure that the arrow on the tube is pointing from the bag to the hand pump. So here's our, if you can see that, there's the arrow on the Traeger tube. It should be pointing to the hand pump. So I will insert this in into the hose. I will insert this in into the little holder device, the little valve on the hand pump, thusly. So basically now I am back out. So now I'm ready to withdraw air from my gas bag full of CO2. So in order to do that, I open my stopcock ball valve and I depress the pump, and I'm now pulling air out of the bag. They say if it takes more than 10 of these depressing and removing from the bag, then somewhere along the way you have a leak. It doesn't look like I'm going to run into that problem here. It also doesn't look like I am collecting any carbonates on my Traeger tube. That's 4. That's 5. Bag is almost empty. That's 6. Getting a little bit of stain. I don't know if you can see it. I'm getting a little bit of a stain area on my Traeger tube here. Not a lot, but this bag is just about done. I think that was 8 pumps of the hand vacuum pump. And we'll say that is 10. I would say there's no leaks in this system, so we're in good shape here. So this is pretty much the conclusion of the test for carbonates. So what we do from here is we do the simple calculation to determine how much we've got. So I would remove the Draeger tube from the hose, remove the Draeger tube from the pump, inspect the stain length. It looks like it goes down to 800. I ran a test a few minutes ago with a higher solution, and if you can see the difference, this is basically unstained. It completely stained out the entire length of the carbonate tube. So here we have a reading of 800. So right here is the blue stain length, and I don't know if you can see that. Yeah, I guess you can see that. Okay, so my formula is the carbonate ions in milligrams per liter and or parts per million is equal to 2.5 times the darkened stain length divided by the sample volume. So in this particular case, I would have 2.5 times 800. That would be what, 2,000? And I would divide that by the sample volume. The sample volume was 2 milliliters, I think. So roughly 1,000 milligrams per liter of carbonate ions that we have in this solution that we rather haphazardly mixed up in the laboratory. So once again, the formula is carbonate ions in milligrams per liter equals 2.5 times the darkened stain length divided by the sample volume that you started out with initially. That's all there is to it. You don't have to bubble this for 10 minutes. This is kind of an abbreviated test. It's a quicker test than running the hydrogen sulfide analysis. And it seems to work pretty easily and pretty well. So this is Larry Mitchell, signing off for the OFI testing equipment Garrett gas train, specifically for the carbonate test analysis.